Good afternoon, everybody. Welcome to Open Source Data Summit 2023. My name is Soumil, and I'll try my best to deliver a session today on maximizing efficiency by templating serverless architecture in Hudi data lakes. So let me share my screen now and begin the presentation. All right, hopefully you guys can see my screen. Perfect. So I would like to introduce myself briefly first. Hey everybody, I'm Soumil Shah. I hold a bachelor's in electronic engineering and a double master's in computer and electrical. You must have seen me on a lot of my YouTube videos because I love teaching people. I make content on Elasticsearch, AWS, Apache Hudi, Glue, Lambda functions, etc., etc. I have expertise in building, data platforms. With me, we also have Divyansh Patel, who's a data engineer at JobTarget. Divyansh, works very close with me at the data team, and he was one of the engineers who worked on building this framework that we are gonna discuss today in the presentation. So I would like to talk who we are. So JobTarget LLC is a leading provider of innovative talent acquisition solution for organization of all sizes. With our comprehensive suite of recruitment, advertising, job distribution, and data analytics tool, we empower companies to find and hire the right talent efficiently and effectively. We offer three core services, which is recruitment advertising. So we offer targeted job distribution solution across a wide range of industries and location, ensuring maximum visibility for a job posting. The second core service that we have is job distribution. Our platform enables seamless distribution of job listing to vast network of job board, social media platforms, and industry specific websites. And the third component is the data analytics. So we provide powerful analytics tool to help companies measure effectiveness of their recruitment strategies, optimize their hiring process, and make data-driven decisions. So I would like to start a little bit about talking about data growth. In today's data-driven world, the volume of data being generated is rapidly increasing. This possesses challenges for organization to effectively manage and derive value from vast amount of information. If you see an image on the right hand side, as of 28th June, our data lake or S3 was at about close to 38.7 terabytes. In a matter of 15 days, now it's close to 40 terabytes, and today it's about 60 to 70 terabytes and more. So managing data growth, right? Some of the challenges that we face, managing this huge data is, data visualization. Presenting large amount of data in a visually understanding manner becomes challenging as traditional visualization techniques may not be sufficient. Data quality, with the sheer volume of data, maintaining its accuracy and reliability becomes challenging as well. Data security. As data expands, ensuring its security becomes more complex. Data analysis and interpretation. Extracting meaningful insights from massive dataset requires sophisticated analytical tools. And last, data processing speed. As data grows, the processing and analyzing it in real time becomes more demanding, requiring more advanced hardware, software, and processing algorithms. So solution of all our challenges that we mentioned before is Apache Hudi. As you know, Apache Hudi, pronounced as Hudi, is a next generation streaming data lake platform that brings core warehouse and database functionality directly to your data lakes. Apache Hudi brings database features to the data lake. It supports stable, transaction, and efficient data handling. Apache Hudi works very well for streaming and batch-oriented pipelines. It's used by major companies like Uber, Walmart, Amazon, ByteDance, and much, much more. It is compatible with open source file formats and any cloud storage platform. Apache Hudi also integrates with popular query engines such as Presto, Trino. You can use Athena, Spark SQL, etc. So some of the benefits that we have seen after adopting Apache Hudi is reporting. So Apache Hudi enables efficient querying of large data set, allowing us faster and more accurate extraction of insight, supporting data-driven decision making. The second point that I would like to cover is eliminating duplicate data. Duplicate data is one of the big challenge in data lakes, and Apache Hudi solves that. Hudi offers a precom key which you can use as a dedupe key, and using Apache Hudi precom key, we were able to remove duplicates from our data lake. We were also able to ensure uniqueness across all the partition using Hudi's global indexes. We enhance data management capabilities. For example, Apache Hudi comprehensive data management framework streamlines data organization, ingestion, transformation, and storage, enabling efficient processing of vast amount of data. Last would be the cost saving part. Apache Hudi saves cost by utilizing Parquet files, which are columnar storage optimized for query performance and compression, reducing the storage expenses. Hudi also offers a cleaner service, which allows you to keep only latest file. So using that, we are able to optimize our storage cost and only keep the latest file versions on our transactional data lake. So now I would like to talk about implementation of Hudi at JobTarget. So how we are using Hudi and the sort of the process of data ingestion, and also how data is consumed once we ingest data into the Hudi, right? So before we do that, I would like to cover some of the challenges that we faced and why we decided to go this particular route. One of the challenges that we faced was maximizing efficiency with our data lake Glue ETL jobs. Our objective was to minimize the infrastructure code, reduce manual intervention, and streamline data ingestion. We had the existing data lake infrastructure and Glue jobs in place. However, we identified the need to improvements to enhance efficiency and reduce manual effort. So let me go to the next slide. Here in this slide, we talk about overall implementation of Apache Hudi. So we have control tower at our organization, meaning each application would have its own AWS account. And then each application will have its dev environment, QA environment, and production environment. So now each application will dump its respective data into the raw S3 buckets. If it's DynamoDB, then we use DynamoDB streams. If it is Mongo, we use Mongo streams. And if it's any other relational database, we probably use DMS to get all the data into the raw zone. Once we have the data in the raw zone, then all the ETL jobs and the Glue cataloging process is done in the AWS data team account. So we read data from these raw S3 buckets through cross account. Once we read the data from these S3 bucket incrementally using Glue bookmark, we ingest that data into a silver zone. Silver zone is where we dedupe the data. These are Parquet files, partitioned properly, right? And from there, we have a framework which will again ingest data from the silver zone into the gold zone. The gold zone is basically the dimensions and fact. Now we have a separate AWS account from where all these data will be queried. So the end user have the flexibility to use either Redshift Spectrum. You can mount Hudi tables or through the Glue catalog, or you can use Spark SQL. Data scientists like to use Spark SQL a lot, so they consume the data from these Hudi tables using Spark. We also have use cases of Athena. A lot of our BI team, they prefer using Athena. And for building all these, dashboards, we prefer QuickSight. And the way we use QuickSight is we, import the data into Spice, and then we build dashboards out of that. All right, so here is how we have implemented this framework. This framework allows us to ingest data into Hudi transactional data lake into a much faster way without writing any infrastructure code. So this way we are able to ship Hudi tables in a much faster way. So let me cover the component. So the advantage of the frameworks are, templated approach, serverless architecture, automated job management, retry mechanism, scheduling via event bridge, enhanced monitoring and alerting. So our data lake solution consists of following components. That is the data storage. We use Amazon S3 to store all our data. And again, we use Apache Hudi for our transactional data lake. We use AWS Glue, where we run all our Spark jobs. We use a Lambda function to orchestrate the job, meaning anytime the cron fires, it will pass the metadata to the Lambda function. The Lambda function will read the job metadata from the DynamoDB. Once it reads the metadata, it will pass all the parameters and it knows which glue job to fire, right? So all the information about that is stored in the DynamoDB. And then once the job start, it knows it knows where to consume the data from the raw zone, and then it will basically build the silver zone. Throughout the entire process, if anything fails, all the events are broadcasted on EventBridge. A Lambda function is subscribed to these events, and it would be looking for failure events. If we do see any failure events, we will basically capture it and we will publish a message on SNS topic. Now, whoever is subscribed to the SNS topic, they will receive an alert that, hey, this particular job has been failed. So that is the overall entire solution. Now, let's probably take a look at the developer journey, how a developer uses this framework to create and set up jobs and create Hudi transactional data lake into a much faster way. So the first approach is to identify the source, right? In this case, on the screenshot, I'm showing you some sample data from S3. So let's say you want to ingest data from customer and order, right? So step one would be identifying the source. Step two, you will create a job. Now, the way we create a job is through an API. This API is hosted on an ECS container and it's written in Python Flask. So let me show you what it looks like. So this is the payload which will create the job, meaning the developer do not have to write any single code. Everything is simply through this payload. So the first section over here is active. So this tells whether the job is active or not, right? The second section you can see is created by. So who is the person who created the job, right? The job name, right? The table name. Now over here we have, if you can observe, if you can see, we have the input path. Let me see if I can take my laser pointer here. Let me see if I can take the laser. All right. So hopefully you guys can see. Let me try to zoom in if I can a little bit. Over here. So as you can see over here, that's the input path. So now the developer will tell, okay, where do you want to ingest data from? So he or she will probably put the input path. Over here, we have the output path, which means where would you want to build the Hudi transactional data lake? Probably the silver zone. Then you can provide the Glue database name, the Glue table name, whether you want to use the cleaner service, whether you want to use the HiveSync service. HiveSync basically means we use, we catalog all the data into Glue, right? You specify the record key, which is also like the primary key of the table. You specify the dedupe key. Usually dedupe key is a timestamp, but you can also use a composite key if needed. Again, we specify the index option. For most of the cases, we prefer Bloom index, but Hudi offers a lot more index. For example, simple. Now, the latest one in 0.14 is RLI, record level index. Now, each job, we know that there would be some transformation needed. For example, let's say you want to extract the year, a month, a day. So we give the developers the flexibility to pass in an SQL query over here. So the developer can simply pass in the SQL query and the transformation will be done on that Spark data frame. So as you can see, this payload over here creates a job. You will create the schedule. It does everything. So you don't have to write any code. The third component is once you execute the job, you will see 200, which means the job is created. You will see the information in the DynamoDB. Here you can see the Glue payload, which means when the job will be fired, the Lambda would read the metadata and all these parameters are passed to the Glue job, right? It knows basically whether the job is active or not. It knows when was this created, who created that, right? So who's the developer who made this, right? The table name and the cron, how often you want to schedule these jobs, right? During the schedule cron, a Lambda function is triggered, which reads the metadata from DynamoDB and fires the appropriate template. So as you can see on this particular screenshot, as soon as you create a job, automatically a dynamic rule has been created. As you can see, this is when this rule would be fired. Automatically a Lambda function is configured as a target and it will pass the metadata. So now the Lambda function receives, will receive the table name, hopefully here, the table name over here and the job name. So it will query DynamoDB and grab all the metadata. It will grab all the payload, right? It will grab the payload and then it would fire the appropriate glue job. Hopefully that made sense. And if something fails, automatically it will retry for 3 times. And after the third failure attempt, it will probably publish an event that, hey, something has failed. So this is how the overall system works, right? So we have all these templates written. So the developer goes in, identifies the source, S3 or any JDBC source. We have templates for different sources. Once he identifies the source, he creates a job through the Swagger UI. And once the job is created, you can verify the metadata in the DynamoDB. And automatically a rule has been created which will fire the glue job on the cron expression that the user has provided. So now let's go to the next slide. This is very interesting, and I would want to talk a little bit about this incremental ETL, right, at JobTarget. So, Hudi offers a feature where you can do incremental data processing on both batch and streaming data, meaning you only process data that has changed in your data lake. Before that, we used to perform an entire table scan, and it was very expensive. As the table grew, the scan would also grow, right? And it would take more and more time to process the data. But with Apache Hudi, things have really changed. So for example, here what we are showing is, as you can see, we have a date dimension. This is a Apache Hudi table which has all the dates from, I guess, 1990 to 2050. That's a date dimension. Then we have an events table. So, we receive all these events from third-party vendors. What we would want to do is we want to map this event to standard event name. So just an example, right? For example, high temperature high. We want to map that to a standard event name called high temperature, right? So that's what we want to do. Then we have a mapping table, Hudi table. The mapping table holds the mapping, the external mapping that the vendors are sending and what we want to map it to internally, right? So that's the mapping table over here, as you can see. And this is the event table. Now, this is a glue job, which will read the data from this date dimension. So it will read the entire date dimension in the memory in Spark. It will read the mapping table. Then over here, it reads data from the events table incrementally. So instead of reading all the data from the table, we incrementally iterate over it. So every single run, we are only processing data that has changed versus scanning the entire table, right? So we fetch those events in an incremental fashion. Then we perform a join operation, and then we upsert into our fact table. The fact table is where we have mapped external events to a standard event, and this is where the business people can query the data and analyze trends on it. So one of our very popular use case of incremental ETL, we use it a lot. We also use Hudi's CDC feature to power downstream system, such as one of them is Aurora Postgres. So we ingest data from Hudi, and then we basically incrementally, and we then populate our downstream use cases, for example, Aurora, Postgres, etc. So now let me derive some valuable conclusion out of it. In conclusion, our data lake optimization efforts through streamlined glue jobs, automated Lambda functions, and efficient failure handling have significantly enhanced data processing efficiency and user experience. Because now we don't need to write infrastructure code. We can ingest data from many sources in a much faster way. And we are building, a lot of Hudi transactional data lake for our, end customers, right? And they can simply query that using either Redshift, Spectrum, or Athena, or Spark SQL, or whatever, their favorite query tool is, Presto, Trino, etc. So we have maximized efficiency by using this approach. Efficient query for large data set, right? Hudi, offers, small file management. So we are able to configure a file size in our transactional data lake, meaning we have larger Parquet files. These larger Parquet files are pretty good for query purposes, right? Also, we use clustering that helps us to further improve the query performance for large tables. Efficient deduplication. So again, as you know, right, Hudi has a pre-com key which allows you to dedupe data. So we use that a lot. Also, Hudi offers global and non-global indexes. Which global index, if you need uniqueness across all the partition, you can go for global index. And in Apache Hudi 0.14 with record level index, the upsert performance is close to 40% faster than global bloom and global simple. Efficient processing. Again, the reason being is we are not processing all the data. We are not scanning the entire table. We are only processing data that has been changed. So we are incrementally processing that. So hence the processing time has went down, and we are saving a lot of money on the compute, right? This entire framework is open source. You can find the entire source code on the GitHub. You can find the Lambda code, the glue ingestion, Hudi template code there. Everything is there on this particular GitHub. So if you want, you can adopt the same or similar solution at your company if needed. So thank you, everybody. Now, if you have any further questions, I am very happy to answer your questions if you have any. And if you would like to connect to me, feel free to connect to me on my YouTube channel or LinkedIn, or you can write me an email at shahsoumil519@gmail.com.